All right, Geometry Advanced. Yesterday you had a brief introduction to area of triangles and parallelograms. Most of this is probably information that you're already familiar with. Hopefully you're pretty familiar with it. That'll make it easier. If not, we'll just dive right in. Remember, your assignment for today is to upload a picture or a scanned image of handwritten notes. Okay, so not typed up. If you want to type your notes up also, that's fine, but you need to handwrite all of these notes so that I know you personally were watching this video and following directions. Let's get into it. All right, the area for a square. This one was not explicitly mentioned yesterday, but it is side length squared. Okay, the square of one of the sides. Remember, in any square, the sides are all congruent. So if one of them is labeled with an S, so are all the other ones. So really, if you're taking the base times the height, then you're still working with S times S, or S squared. All right, a little bit more that we did not necessarily talk about yesterday. If two polygons are congruent, then they have the same area. That should make sense. If two squares are the same, then the area of the squares would be the same. The area addition postulate is also something that should be kind of intuitive. The area of a region is the sum of the area of its non-overlapping parts. For example, if I wanted to know the area of this shape, okay, we'll just put a trapezoid up for now. If I wanted to know the area of this trapezoid, I could break it into a triangle and a rectangle. And if I were to add those two areas together, then that would be the area of the whole thing. That's all that this is saying. All right, again, as we're going through this, if you need more time on any particular problem, go ahead and pause the video, and then you can resume it when you're ready to move on. All right, this one you should be familiar with. The area of a rectangle is the product of its base and height. It doesn't really matter which one you label as the base and which one you label as the height, because you're multiplying them together anyway. So again, pause it if you need more time to write this down, but I won't dwell on it since you should know this one. All right, the area of a parallelogram. Yesterday you saw that this was also the same as the area of a rectangle, and you kind of saw that video about why. So we've got a little note at the end here. The height must be perpendicular to the base. So if we call this the base down here, the height is not going to be one of the sides usually. Okay, that's only true if it is a square or a rectangle. The height needs to be perpendicular to the base. It can occur inside or outside of the parallelogram. So for example, this could be our height here inside, as long as it's perpendicular to the base. Or this could be our height out here, again, as long as it were to be perpendicular to that base. It's just shown outside instead of inside this time. That's fine. So these are the same height. One is shown inside, one is shown outside. Okay, pause it if you need more time. Write down any questions you need to email me. I'm going to keep going. Oh, there it is. All right, the area of a triangle is 1/2 the product of the base and its corresponding height. Again, height must be perpendicular to the base. Sometimes it will occur inside, sometimes it will occur outside. Technically, it could even be part of the triangle if it's a right triangle. So that's a special situation we might see. This time, our height, if we consider this bottom side to be our base, then our height would be inside of the triangle. Close to being good. And remember, for a triangle, it's 1/2 times the base times the height. Okay, again, pause, rewind, write down questions. I'm going to keep moving. Okay, so we've got parallelogram PQRS. We know that to find the area of a parallelogram, we need to take the base times the height. So you have to determine what is your base and what is your height. The base is probably more obvious, at least I hope so. Our base that we would use is SR, which has a length of 10. Then we just have to decide what we're multiplying that by. Remember that the height needs to be perpendicular to the base in any of these problems. So we cannot use 20 as the height. We have to use the 15 because that's the one that is perpendicular to the base. Even though it is outside of our parallelogram, you have to use the one that's perpendicular to the base. So in this case, our area would be 150. And we should have some sort of units, so I'll just put units squared on there. Usually this would be things like inches squared or feet squared, centimeters squared. If you don't already have this ingrained in your brain, you might want to make yourself a little note that for area, units are always squared. Okay, for things like perimeter, they'll just be regular units. If it's area, the units are squared. And when we get to volume, you'll see the units are always cubed. All right, let's move on to the next one. All right, for number 2, we need to find the perimeter and area for both of these. So if you need to pause this to have time to jot these diagrams down, that's fine. Go ahead and do that now. If we're finding the perimeter for letter A, remember perimeter is just adding up all of the sides. They have 2 of the sides labeled for us, 5 and 20. Okay, so that accounts for these 2 sides. But to find perimeter, I need to add up all of the outside edges. So this side on the right here is going to be another 5. And the side down at the bottom is going to be another 20. So my perimeter altogether would be 50. Let's go ahead and label these with inches. Okay, so my perimeter is 50 inches. And then that's all there is to it for perimeter. For perimeter, we will not use any segments inside or outside of the figure, only the edges of the shape itself. For area, well, I'm going to go ahead and tell you this is a parallelogram, so we need to take base times height. The base of this time it wasn't labeled on the bottom, but it's the same as the top because it's a parallelogram. So my base has a length of 20. The height needs to be perpendicular to that base, so my height this time is 4. I am not using the 5 when I'm calculating my area. Okay, 20 times 4 would be 80. Our units would be inches squared. Okay, so we found perimeter. And we found area. If you need more time with that, go ahead and pause the video here because I'm going to kind of cover all that up to make myself enough room to talk about letter B. So pause now if you're not done with 2A. All right, for 2B, again, the perimeter is just adding up all the outer edges, not any of the edges inside. So we would take 18 plus 16 plus 22. Let's give these all centimeters. Centimeters. Just so we've got some units to work with. All right, so when I add up all my outer edges, I get 56 centimeters for my perimeter. And that's all we have to do. Then for area, this is a triangle, so our formula is 1/2 base times height. Remember that the base and the height need to be perpendicular to each other. So my base this time I have to use the 22 and a height of 13. If we had drawn in some of the other altitudes or heights, we could have used a different base. For example, if I had, I'll do it in red, if I had this altitude here, it looks like it's about perpendicular. If this altitude were perpendicular here, I could use a base of 16, but I would need to know that height. Okay, so there are different options. You just have to use what you're given. All right, so 1/2 of 22 is 11 multiplied by 13, and that would give me 143. My units should be centimeters squared. So again, I've got my perimeter and my area. That's what they asked for. Pause it here if you need more time. I'm going to move on. All right, the base of a triangle is twice the height. The area of the triangle is 36 square inches. Find the base and the height. If you really want to draw yourself a little diagram, you can. I don't know that that's necessary. I think we just need to use our area formula and what they told us. So if we are working with a triangle, we should know our area is equal to 1/2 base times height. They told us that the base is twice the height, or 2 times the height. Base is 2 times or twice the height. And they told us that the area is 36 square inches. So I am going to plug in for B and plug in for A, and that should allow me to find my height. So what I mean is, instead of writing an A, I'm going to put 36 1/2 times. Instead of a B, I'm going to put a 2H. I'm just plugging it in, and I'm multiplying that by another H because that was in the formula already, and I'm not replacing it. We can simplify the right side a little bit. Okay, 1/2 of 2 would just be 1. So this ends up being 1H times H. H times H is H squared. And then to get H alone, we just have to square root both sides. And we should get that H equals 6. If our units for area were inches squared, then the height would just be inches. But they didn't just want the height, they wanted the base and the height. Luckily, we know the base is twice the height. So that would make the base 12 inches. It's 2 times the height. So there would be our 2 answers. Again, pause it, write down your questions. I'm going to keep going on to example 4. All right, example 4. The base of a triangle is 1/2 the height. The area of the triangle is 64 square centimeters. Find the base and the height. This will be a lot like the last problem. Use the formula for the area of a triangle. Area equals 1/2 base times height. Use the information they gave you. The base, or B, is equals 1/2 the height, or 1/2 h. And the area is 64 square centimeters. Take that information and plug it into the formula. So instead of A, we've got 64 equals the 1/2 that was already there. Instead of putting a B, I'm going to use the 1/2 h, and then we have the other h that was already in the formula. Simplify things a bit. If you take 1/2 of a 1/2, you get a 1/4. Okay? Or just multiply your fractions. 1 times 1, 2 times 2. H times h again is h squared. This time we need to get h alone, so first we are going to have to multiply both sides by 4, or 4 over 1, multiply by the reciprocal. So on the right side, those are going to just cancel out, leaving us with h squared. Now on the left side, if you want to go ahead and multiply 4 times 64, you can. I'm going to leave them separated, and the only reason I'm doing that is because they're both perfect square numbers already. So I am not going to bother multiplying them together, just because I can already see that when I need to take the square root, that's going to be a little bit easier on me. The square root of 4 is 2. The square root of 64 is 8. And 2 times 8 gives me a height of 16 centimeters. Now, if you wanted to multiply them together, that's fine. I'll show that up at the top. If you take 4 times 64, you should get 256 equals h squared. And then when you square root them, you still get 16. So either way, it's fine. I just like keeping my numbers smaller since I knew they were both perfect square numbers anyway. Same answer either way. All right, but we're not done yet. They wanted the base and the height. So far, we just have the height. Luckily, they told us that the base is equal to 1/2 of the height. So the base would be 8 centimeters. So there are the 2 parts of my answer. Again, pause it, write down or email me your questions or concerns. Make sure you're keeping track of your units when possible. A lot of the times, if I have you submit answers in a Google form, we might not worry about units because they're a little trickier to type in. But if possible, it's nice to show your units. All right, next one. Find the area of the region. So they mean this whole area bound by all of our letters. So just this whole thing. I'll highlight the entire thing so you understand. We're finding the area of this shape. Let's see, 1, 2, 3, 4, 5, 6 sides. So this hexagon. It's a concave hexagon. All right. In order to do this, we need to break this up into regions that we could then add together. So I'm going to label those regions as A, B, and C. Remember, if we're going to use our area addition postulate, the regions cannot overlap. So I'm looking at A being a triangle, B is a parallelogram, and C is another triangle. Let's start with the parallelogram just because that, in my opinion, is going to be the easiest. So the area of region B is going to be the base times the height. Oh, I lied. Let's not start with that one. Let's start with region A. Sorry, I'm going to back it up. Let's start with region A. This problem is going to require a few steps just because we don't know things like this base right here. We don't know that. So we have to find that. Remember, we can't just use the 25 and the 20 that they gave us because those are not perpendicular to each other. So in any shape, your base and your height need to be perpendicular. So the first thing we're going to find is just VU right here. This is a right triangle, so hopefully when you look at this, you know that you need to use your Pythagorean theorem. So A squared, let's just say 20 squared plus, we don't know that little b down there, squared is equal to C, or the hypotenuse squared. Take a moment and figure out what b is. All right, if you use your Pythagorean theorem, hopefully you found that this little side right here has a length of 15. Okay, I've got that work shown right here. We are going to need to do the same thing to find UW. Use a different color. We are also going to need to find UW. So let's go ahead and do that real quick. So on this one, our A would be 28 squared plus b squared equals our hypotenuse is 35 squared. So go ahead and take a minute to find this segment, and then we'll keep on going. All right. This time we found that UW, or this side of this triangle right here, should have a length of 21, also using our Pythagorean theorem. Okay. So now we should be set up with all the missing information we need. The only other thing that I want to point out that might not be super obvious would be the height of this parallelogram. Again, remember that your base and your height need to be perpendicular. I'm going to show it over here, going down from S. There we go. Okay, so this perpendicular height here, can anybody see how long that should be? Well, if you look all the way over on the left side, that's the same distance as RV. It has a distance or length of 20. So it would be the same inside here. Okay, so I know this diagram's getting awfully busy, so let's focus on one section at a time. Let's first work on the area of section A. So section A is a triangle. If you want to write that down. So our area for section A is 1/2 base times height. Our base we found is 15. The height is 20. Okay, now you can do this in any order you want. You could take 1/2 times 15 and get 7.5, then multiply it by 20. You could take 15 times 20 and then use half of that. Whichever way you want to do it is fine. You could even take half of 20 and then multiply it by 15. But any way you do it, you should be getting your area for that section to be 150. Okay, and again, those would be units squared. They didn't put units on there, so we won't worry about them. So we just need to set that aside, and we are going to move on to section B. Section B is a parallelogram. So our area is equal to base times height. Our base this time is 35. It is not going to be the whole length here. We're not going to add those together. It's just the parallelogram base, which is 35. And the height, again, we talked about, has to be perpendicular to it, which is 20. So when we multiply those, our area would be 700 units squared. All right, last up, let's look at section C, which is another triangle. So we are again using area equals 1/2 base times height. The base and the height need to be perpendicular. That's why we had to find this last side here that formed our right angle. So when we substitute in our base 21, our height 28, again, multiply these in any order you would like. But no matter how you do it, you should be getting an area of 294 units squared. So we found our 3 sections. The last thing to do would be to add them all together. So for our total, for this whole hexagon, our area is going to be 150 plus 700 plus 294. So I am getting a total area of 1,144 units squared. Okay, so we had to find the area of all the pieces. In order to do that, we did need to find a couple missing lengths, especially inside or on those triangles. All right, I'm done with this problem, so I'm moving on. If you need more time, pause it or rewind. This is our last example for today's notes. You need to buy paint so you can cover the back of an A-frame house and the top of a deck. If you're not familiar with an A-frame house, here's a picture kind of in the background. My brother lived in an A-frame house in Carbondale during college. They're pretty cool. All right, a gallon of paint covers 275 square feet. How many gallons should you buy? So the first thing that you need to do is to figure out the surface area, we would call it, the area of both this side of the house and of the deck. Now the area of the deck is not going to be all that hard. It's just a rectangle. So for the deck, your area is just base times height, or 30 times 9. And that would be 270 feet squared. So that part's easy. Now we just have to worry about the area of that side of the house. Notice that we have an isosceles triangle. Those lengths are the same. So when we drop that altitude down the middle here, we're trying to figure out that height. We've kind of got it as a dashed line. I'm going to make it a solid line. This height is what we need to figure out. So when we have an isosceles triangle, it's going to split this base in half. So on this side, we would have a length of 15, just from the middle there out to the side. And now we have a right triangle, so again, we could find the height of the house. So this time I'll use h squared plus 15 squared equals 38 squared. So I'm using this right triangle that I formed with half of the side of the house. All right, so if we solve for h here, we get approximately 35 feet. I'm okay with rounding up to the nearest whole number because it was 34.9, and we would be better to overestimate how much area we have than to underestimate it. So 35 feet is okay for our height here. So if we're finding the area of the face of the house, I'll do that up at the top. The house has a face that's a triangle, so we would have to take 1/2 base. The base down here was 30. We used the whole base. Times the height was 35. When we multiply all of those together, we should get 525 feet squared. So the total area we're trying to cover, we need to add those together, kind of like the last problem. So 270 plus 525 would give me 795 feet squared. But that's not what they asked for. They didn't ask for the total area. We just needed to know that so that we could figure out how much paint to buy. So a gallon of paint covers 275 square feet. 1 gallon of paint obviously is not going to be enough. I don't think 2 would be enough. To figure that out, we would need to take 795 divided by the 275. And that would give us about how many gallons we would need to buy. Okay, so it's coming out to be about 2.89, and then it keeps going, 090909. Now, usually when you go to Lowe's or Home Depot or wherever you buy your paint, you cannot just say, I need 2.89 gallons. They would require you to buy a whole gallon. So to make sure we definitely have enough paint, we would need 3 gallons of paint. And that would be our final answer after all of that work. Again, pause, rewind, email me questions. Make sure you upload a picture or scanned version of your handwritten notes today.